Alright, so in today's video, I'm going to go ahead and go over the second part to solving quadratic equations by factoring. On that half sheet of paper that you should have picked up today, what I want you to go ahead and do is try to solve this quadratic equation by factoring. One of the most important steps we took whenever we try to factor a quadratic equation is make sure that we set our y equal to 0. So I'll just go ahead and show that here. And going back to the previous video, the way we would solve this quadratic equation is we would set up a sum and product puzzle to help us factor this equation. Multiplication on top, addition on the bottom. And what we would do in this case is we would put the last number, which is 208, on the top of our puzzle. So we want two numbers that multiply to give us 208, but we want those two numbers to add to the middle term, which is positive 29. This right here is the most difficult part, finding out these two numbers that multiply to 208 and add to 29. So let's just say you're having a hard time figuring these two numbers out. What we could do is use Desmos to help us out. And on Desmos, what I'm going to go ahead and do is call these two numbers x and y. I want two numbers x and y that multiply both to 208, but I want them to add, so x plus y, I want them both to add to 29. So these two equations I'm going to type in on Desmos, xy equals 208, the top number. We want those two numbers, whatever x and y are, to equal the bottom, 29. You may have to zoom in, zoom out, but if you look at the intersection points, what's really nice about Desmos is that it'll give you those two numbers. The two numbers here, no matter what intersection point you look at, are 13 and 16. You can also look at it the other way around, 16 and 13. It doesn't matter what order, but here your two numbers are going to be 13 and 16. So from that, I can factor this equation with two parentheses side by side, put x and x inside, and then we'll place those two numbers inside our parentheses. So positive 13, positive 16. We then set each of these factors equal to 0. So I'm going to set x plus 13 equal to 0 and x plus 16 equal to 0. I'll then have to solve for x in both cases. I'll subtract 13. We'll get x equals negative 13. Here I'm going to subtract 16. Here we'll get x equals negative 16. These right here are our solutions. Once again, they can also be referred to as the roots, the zeros, or the x-intercepts. And one thing I want you to notice before we move on to the lesson is, notice that when we go to these factored forms, our answers are ultimately opposites of each other. So that's one thing I want you to be thinking about. All right, so make sure you have this written down on the half sheet of paper. In terms of the lesson here, you should have picked up this paper today. What I want to go over is a couple of examples here, just to make sure we practice more with the second part of the factoring process. Let's look at example number 2. In example number 2, they want you to factor this equation right here. But one of the most important things we got to be able to do is figure out if there's a number that we can divide all three of these by. What we call that number is the greatest common factor, also known as the GCF. Here, all these three numbers can be divided by 5. Let's just say you're having a hard time finding the GCF. On Desmos, I can type in GCF, put in these three numbers that they give me. I'll type it in like that. GCF, parentheses, 5, comma, negative 20, comma, negative 60. And it will give me the number that they're all divisible by, which is 5. So my GCF here is 5. What I'm going to go ahead and do with that GCF is divide each of these by 5. I'll get 5 divided by 5. That'll give me 1x squared. Negative 20 divided by 5 will give me negative 4. Don't forget the x. And the negative 60 divided by 5 will give me negative 12 equals 0. But we can't just let that division of 5 disappear. We have to incorporate it back into this equation. So I got to put two two parentheses right here. And in front of the parentheses, I got to put the greatest common factor, which is what we divided by, which is 5. So I got to make sure I take into account the 5 in the beginning of this equation. Now that we've factored out the 5, notice on the inside of the parentheses, our a value is 1. So now we can go ahead and go straight to setting up our sum and product puzzle. Last number here is negative 12. That'll be on top. And in the middle, we'll have negative 4. Sorry, in the bottom, we'll have negative 4. And once again, this is the hardest part, finding two numbers that multiply to negative 12 and add to negative 4. We could do the same process we did in the other example, x times y. We want that to be negative 12. And we want these two numbers, x plus y, to equal the bottom number, which is negative 4. You may have to zoom in, zoom out. But if you look at the intersections, it'll give you those two numbers right off the bat. So we have 2 and negative 6. I can then factor this equals 0, x and x, and I'll put in those two numbers we got, positive 2 minus 6. Don't forget the 5 is still outside. And then at this point, what we want to do is set each of these equal to 0. I'll only show it for this one example, but if I set 5 equal to 0, this is a false statement. I don't even have to worry about this. So whenever you have a number outside, you don't really have to worry about that number affecting your answer. The most important part are these terms right here, x plus 2 and x minus 6. I do have to set each of them equal to 0 and solve for x. But here you can take advantage of that pattern as well. Your answers will be opposite signs. Here you'll get x equals negative 2. You'll add 6x6, and here you get positive 6. So these right here are my solutions, my roots, my zeros, or my x-intercepts. So I want you to be thinking about how we can incorporate the GCF, factor that out, and then factor out the remaining quadratic equation from there to help us find our x-intercepts. All right, let's look at example number 4. In example number 4, very similar idea. First thing we want to do is always check to see if there's a greatest common factor between all three of these numbers. I can type in GCF. 8, comma, negative 22, comma, 5. According to this, the GCF is 1. I can divide all these by 1, but that wouldn't change anything. So at the end of the day, my GCF, my greatest common factor, is really not applicable. I don't have to worry about it. But the problem is that my a value is greater than 1. So if you come across a situation like this, where your a value is still greater than 1, without any GCF present, we have to come up with a new method called the slide method to help us out. So I'm going to go ahead and rewrite that equation they give me. And here's what the slide method allows us to do. It allows us to grab this 8 and multiply it by our c, by that last number. So here, I'm going to go ahead and slide the 8. So the 8 will temporarily go away. I'm left with x squared. Keep the middle. 8 times 5, that'll give us positive 40. Bring down equals 0. And then now notice that in the very front, I've created a situation where my a value is 1. Now I can go straight into my sum and product puzzle. Last number is 40, that'll go on top. Bottom number is negative 22. And once again, I have to solve this puzzle out. I can do x times y equals 40. And then those two numbers must equal negative 22. I can zoom it out. And if you look at the intersections, those two numbers are going to be negative 2 and negative 20. From here, I have two parentheses side by side. X and x. I'll place those two numbers in. But here's the most important part, the most critical step that a lot of students forget. Whenever you use the slide method, we can't just make that 8 disappear. We have to undo that multiplication that we did with the 8 in this step right here by dividing each of these numbers by what we slided, which is 8. So at this point, my goal is to be able to reduce these fractions, if possible. So on the side here, I'm going to type 2 divided by 8. If I click the little fraction icon, that'll give me 1/4. So I got x minus 1/4. I'll also put 20 divided by 8. If I click the fraction icon, that'll give me 5/2. X minus 5/2. And according to the slide method, it states that once you've reduced the fractions, what you're going to go ahead and do with the denominator is move it next to the variable. So I'm going to do 4x minus 1, and then 2x minus 5. Now we're one step closer to finding our solutions. All we have to do now is set each piece equal to 0. I don't have enough space here, but I'll jump over. We'll have 4x minus 1 equals 0. And then 2x minus 5 equals 0. I'll solve each of these for x. I'll add 1, where x equals positive 1. Divide by 4, divide by 4. We'll get x equals positive 1/4. Here I'll add 5. So x equals 5. Divide by 2. And you get that your other x value is 5/2. These right here are your solutions, your x-intercepts, your zeros, your roots. But one thing I want you to notice is that our answer was lying right here, hidden in the factoring process. So once again here, you have that situation where you have opposite signs. So those are problems I want you to be thinking about already. I'll go over one more example today. Let's go over to the back. Question number 10. Wind up with this one. In number 10 here, notice that it's not in standard form. We want this equation to be in standard form. We want one side of it to be equal to 0. So what we have to do is move one of these terms over to the other side. What I recommend here is moving the 10x over to the other side. We subtract 10x, subtract 10x. Nothing's going to happen to the 8x squared. The 10x will be placed in the middle because our x term here will be placed in the middle. And our c term, which is plus 3, will be set at the end. Once again here, I check to see if there's a GCF. That'll help me divide all three of these numbers. I can type it in. And it turns out that I don't have any GCF. But my a value is greater than 1. Therefore, I'm forced to use the slide method to help me factor and solve. So the slide method tells us to slide the 8 over and multiply by the last number. So I'm sliding the 8. The 8 will temporarily go away. Keep the middle term. We'll have 8 times 3, which is 24. And then now notice our a value is 1. Now I can set up a sum and product puzzle. Last number will go on top. Middle number will go on the bottom. And then I have to solve this puzzle out. We do x times y. We want that to be 24. And we want those two numbers to be equal to negative 10. If I look at the intersection, I might have to zoom in a little more. Those two intersections right here are negative 4, negative 6. And those are my two numbers. So I'm going to factor this out. X and x. Minus 4, minus 6. And here is the critical step. We got to make sure we divide each of these. But what we slided the 8. And then after that, our goal is to reduce these fractions that we have right there, if possible. So we have 4 divided by 8. That reduces to 1/2. And then we have 6 divided by 8. That'll reduce to 3/4. Once you've reduced the fractions here, The slide method tells us to move the number in the denominator over to the variable. We'll have 2x minus 1 and 4x minus 3. After that, we set each piece equal to 0. So we have 2x minus 1 equals 0. And then 4x minus 3 equals 0. But I kind of already want to let you know, your answer should be opposite of what is given right here. So here, if you solve for x, you should get positive 1/2. And then here, if you solve for x, you should get positive 3/4. And those are our solutions, our roots, our zeros, our x-intercepts. So I will make sure to come back to this in class when I return. All I want you to do today is work on the Delta Math assignment. Once you're done with that, on the back of the half sheet of paper, what I want you to work on is this problem right here. Try to solve this out on that half sheet of paper I gave out on the back. Once you're done with that, turn it into the bin. And that's pretty much it for the day. Once again, work on the Delta Math assignment and this on the back of the half sheet of paper, work on this problem. If you have any questions, let me know. I'm always happy to help, and I hope you have a great day.